Okay guys, we're going to start out today by talking about the different sets of numbers. You might not realize what I mean by sets of numbers until I give you a couple examples here. So stuff like integers, whole numbers, real numbers, and there's lots, so I'm going to say and etc. there. Those are what I mean by sets of numbers. So I'm sure once I wrote those down you're like, okay, I get it. Now, we're going to come back to this question, what is the largest set of numbers, after we fill out this little tree diagram here. And we're actually going to start by looking at the bottom, and I have to add a box here. The set of numbers that is the smallest, so doesn't have as much in it, we're actually going to start with what's called the natural number. So you may remember this from last year. That starts at 1. And you just count upwards forever. If it's a nice positive whole number, you got yourself a natural number. Now, the next smallest group are the whole numbers. And the only difference is that a whole number contains 0. After that, it's just like the natural numbers. After the whole numbers, our next biggest group of numbers are the integers. Now, integers are positive and negative whole numbers. So still no decimals or fractions, but now we can talk about negatives. So they are the whole numbers plus the whole, negative whole numbers. Now, from there, our next two groups are rational and irrational. Rational numbers means the decimals either end or repeat. Irrational means that your decimals don't end or repeat. Okay, if you think about the word irrational, if somebody is behaving irrationally, their behavior doesn't make sense. So if a number is irrational, its decimal doesn't make sense. It doesn't follow a repeatable sort of pattern. Now, all of these types of numbers, these sets of numbers, fall under the umbrella of being real. So a real number is basically numbers that behave nicely and numbers that don't behave nicely. Decimals that end or repeat, decimals that don't end or repeat. Okay. For most of what we do in math class, we're almost always working with real numbers. But there is a set of numbers that is not within the set of real numbers, and those are called imaginary, and that has come up already in this chapter. The imaginary numbers, as you might remember, include an I. So that's what I'm going to put for right now. We're going to get into more detail with that. Now, both of these types of numbers fall under the umbrella of what we call a complex number. Now, we will talk in detail about complex numbers tomorrow. Today's focus on this video is imaginary numbers, but complex numbers, those are your largest set of numbers. Okay? So, if we come down here, we're going to focus on these imaginary numbers, and we're going to start by talking about I. Those should be a review. When we see this lowercase I in math class, it's called the imaginary unit. I wish they had given it a different name. Imaginary sort of implies make-believe or made up or invisible. That's not true. Just because this is imaginary doesn't mean it's sort of this mysterious magical thing. But I is the imaginary unit, and we utilize I when we have a negative underneath the square root. So a key thing to remember, maybe put a star by it, is that the square root of -1, that is equal to I. Mathematicians were having issues because they wanted to be able to square root a negative, but if you only consider real numbers, you can't really square root a negative, but if you allow yourself to sort of think outside the box a little bit and say, okay, this is going to be equal to this thing called I, it kind of allows you to keep solving some problems. So using common sense here, I squared, if I square this right-hand side up here, if I square this side, well, I should also square over here. So if you think about what happens when you square that square -1, that's going to be important. Okay? Okay. I'm just going to start by looking at a couple square roots that have some negatives in them. So if we look at the square root of -25, think of that as you know this is an I, and this is a 5, and you're multiplying those together. So we would actually write that as 5I. If we look at the one below it, the square root of -36, again, we're multiplying them together. Running out of room here. And that gets us 6I. Now the other two are a little more complicated. Okay, now we know this is an I. This is a 2. Square root of 30 isn't something that's nice. Even if you try to break that apart, we got 1 in square root of any of those, so that's after a nice like that, but before the square root. To be honest, the order really doesn't matter. If you had an I in front of 2, that would be fine with me, or an I after the square root, that's okay. 2, an I, and a times the square root of 2. You know this is I, this is 5, and this can't simplify. So you've got 5I